Oh, right, I forgot to finish my main statement. I overran my time, that's okay. So, let's see, I'm gonna put here, I'm gonna put system sketch, and I have to include the library for that, which is conio, conio.h, and I'm gonna just close the brackets here because. So let's check this out, and the sum of the two numbers is 24. Let's go back to the numbers. 7 plus 3 and 16 plus 7. Yes, the sum is 24. That's such a nice sum. So let's actually copy this over and let's test it out for all of the. So the difference, I forget how to say the quotient, you know, here the result of multiplying the two numbers is my calc. So here we have my calc multiply, multiply. Here we had my calc subtract, divide, power, I think, and absolute, negative 99. So absolute value of 99 is the power of the first the power, let's just call it the power so we need an escape character for both of these. The power of the two numbers is my calc power, my calc divide. So that's it, and now I can, let's check this out. So the sum of the two numbers is 20. Oh, sorry. The sum of the two numbers is 24. The difference of the two numbers is negative 9.4. The result, by the way, we could put an absolute value and it will give us always the positive difference. It doesn't matter. The result of multiplying the two numbers is 121.91, and I'm too lazy to multiply them out. But actually, if we start out I went to the wrong thing. Calculator. Okay, calc. We can start up here and we can fool around with the two numbers. I had 16.7, I think. 16.7 times 7.3, something like this. Oops. 7.3, 121.91. So ours is correct. The quotient of the two numbers is that number. I believe that. The power of the two numbers is some big number. I believe that. And the absolute value of negative 99 is 99. So here we put negative 99. How about, let's just say that we decided we wanted integers right away, and I can change this from double to an int, and now run this again. And you see, like, all of our results are integers, and the quotient of the two numbers is 0 and something like that. So let's see. Mm. Now it throws us an error because it says we're passing doubles, but we called it as an integer, but we know, so we can do this with whatever. You can do this with a character, although that won't be really useful because let's see what happens. I bet it will throw an error actually. And now you have these little characters popping up everywhere because yeah, the quotient even doesn't show up, but these show up as the characters, probably by the ASCII symbol. I've never seen this one before, but so you could say this with string. That's the purpose of templates. You can do anything. Well, in this case you can't, because it doesn't take a string. So calculator float, I can put it as float and it will do the same thing. Doesn't matter. So float does the same thing as a double. You can put a long, a short, long, unsigned, long, int. And now you get this huge number here and here and here. So that probably wasn't smart. Unsigned double. I could do this though, and let's see what we get then. So, well, unsigned double doesn't make sense really, but so yeah, basically you can do this with any data type. And here's our class. It's really simple and it's really dubious. So yeah, that's it. And I hope you enjoyed this lesson pretty much. So as you understand, templates are there for making things easier. So if you want to make a separate class for double, for float, for string, for an integer, but they all do the same thing, you can just put a template with a type name T and then refer to that template and reuse your code really efficiently. So this comes in handy. And sorry, I still haven't woken up yet. So yeah, I hope you enjoyed this lesson and I'll see you soon.